Exercise 5. I have skipped exercise 4 because it was very much similar to exercise 3, which we have already done. Exercise 5. Estimate the theoretical fracture strength of a brittle material if it is known that fracture occurs by the propagation of an elliptically shaped surface crack of length 0.28 mm and having a tip radius of curvature of 1.2 into 10 to the power minus 3 mm when a stress of 1200 megapascal is applied. Okay, so for this question we know that the maximum stress at the tip of the crack is equal to 2 times A over I'm missing something over here, 2 times the applied stress into A over rho T power 1 by 2. So now we know that this applied stress is equal to 1200 megapascal, and A is the length of the surface crack. Length of the surface crack, so it is 0.28 millimeter. And divided by radius of curvature, which is 1.2 into 10 to the power minus 3 millimeter. So 1.2 into 10 to the power minus 3 millimeter. Remember that both these units are in millimeter and they are having a ratio, so therefore we don't need to convert them into meters. So if I solve it for sigma m, then I will get a value which will be equal to, so this value will be equal to 36,660 megapascal, or in other words it is 36.66 gigapascal. Okay, a polystyrene component must not fail when a tensile stress of 1.2 megapascal is applied. Determine the maximum allowable surface crack length if the surface energy of polystyrene is 0.5 joules per square meter. Assume a modulus of elasticity of 3 gigapascal. Polystyrene is a lightweight material, and then its strengths are also relatively low, as you can see from these values as well. But anyway, for this question, we can find the critical stress value for failure by this formula. So the critical stress value for the failure can be found by this formula. So it is equal to 2E gamma S over pi A power 1 by 2. So where E is the modulus of elasticity and gamma S is the surface energy of the surface energy in terms of joules per square meter. So simply we input these values over here, 2 times 3 into 10 to the power 3, or maybe 9, just convert it into megapascals. Gamma S is 0.5 joules per square meter, and divided by pi, and A is basically we need to know, and then A we need to know, and then gamma C is the limiting stress. So the critical stress here it will be 1.25 megapascal. So since we are all converting those values into pascal, so it will be 10 to the power 6 over here, and then 1 power 1 by 2. So I think we need to solve this equation. The steps for the solution I will not show over here. I will just simply calculate the answer, and then I will put the answer over here. So this value will be 0.61 into 10 to the power minus 3 meter. This means that it is 0.61 millimeter. So this will be the length of the crack, allowable length of the crack in this case. Okay, next. Some aircraft component is fabricated from an aluminium alloy that has a plane strain fracture toughness of 35 megapascal square meter 35 megapascal meter power 1/2. It has been determined that a fracture results at a stress of 250 megapascal when the maximum or critical internal crack length is 2 millimeter. So for this component and alloy, will the fracture occur at a stress level of 325 megapascal when the maximum internal crack length is 1.1 millimeter. Okay, so in this question, two conditions have been given. In the first condition, the stress level is 250 megapascal and the internal crack length is 2 millimeter. Okay, remember that the internal crack length is actually 2a. Okay, internal crack length is 2a. Okay, it should be taken as 2a. Okay. So if you take these fracture mechanics diagrams, so if the crack length is, if there is an internal crack, then that length is actually 2a. Okay, so internal crack length is 2a, so 2a is 2 millimeter, so a will be equal to 1 millimeter. Okay, so we must remember this, that we need to use 1 millimeter. So now we have this equation, kc is equal to y sigma c under root pi a. So in this case, kc is the fracture toughness value, 35 megapascal, and y is not given in this case. We cannot assume simply y is equal to 1 in this case. Y is not given, and we say that because for 250 for a stress of 250 megapascal, the crack occurs when the internal crack length is 2 millimeter. So therefore we will use 250 over here and under root pi, and then a, as I have mentioned over here, I will use 1 millimeter, or it will be then 0.001 meter. Okay, so from here you can find the value of y, which is equal to 2.5. So the value of y is 2.5, and it is a dimensionless number. Now for the second situation, we still can use this equation. So for the second situation, we know that the value of y is 2.5. Okay, and the fracture toughness value is 35. Okay, and then we assume that although it has been asked that whether it will, at this stress, the fracture will occur or not, but we assume that we need to find this stress value, the critical stress value. What will be the stress value when the fracture will occur? So we can put pi over here, and then now in this case the internal crack length is 1.1 millimeter, so therefore it will be 0.0011, okay, divided by 2. Okay, so this is the internal crack length, half of that should be taken. So from here we can find the value of the stress needed for this crack to occur. Okay, so I will calculate this value of stress. So sigma c over here it will be 337 megapascal. Megapascal. So now this 337 megapascal is the critical stress value, which is greater than the stress level of 325 megapascal. So the applied stress is less than the critical stress. So therefore in this case we can say that there will be no cracking. Okay, will the fracture occur? So we can say that fracture will not